In today's video, we are going to learn part 2.4 of chapter 2 where we are going to look further into salts. So what are salts? Salts are the compounds that are formed when an acid and base react together. This particular reaction is called neutralization, where H plus ions from acid combine with OH minus ions from base and form water, and a salt is also formed in this reaction as a leftover or as a precipitate. For example, when a strong acid such as hydrochloric acid reacts with a strong base such as sodium hydroxide, we get NaCl, which is called as table salt or the salt that we use in our food every day. So this particular salt has a neutral pH of 7. Some more common salts that we use in our everyday life that are formed by reaction of acids and bases include baking soda, which we also call sodium bicarbonate. This is a basic salt that is formed by the reaction of a weak acid called carbonic acid with a strong base, that is sodium hydroxide. This particular salt has a slightly alkaline pH, and this is used for baking, cleaning, and also to treat heartburn. This salt has a slightly alkaline pH and it's usually used in cooking, baking, cleaning, and also to treat heartburn. Another common salt is calcium carbonate. This is found in chalk that we use for writing or in limestone, or it is also used in some antacids. This is formed from a weak acid, carbonic acid, and a strong base, which is calcium hydroxide. Ammonium chloride is another common salt which is usually used in cough syrups and fertilizers, and this is formed by the reaction of ammonia with hydrochloric acid, and it has a pH of less than 7. Out of the common salts that we see, two salts that are used in cooking are sea salt and rock salt. So sea salt is derived from the evaporation of seawater, which is typically white in color. This is used in cooking, skincare, as well as bathing salts. This contains trace minerals like magnesium, potassium, and calcium. Pink salt or rock salt, on the other hand, is mined from underground salt deposits, and it is a remnant of ancient seas. So the color can be pink, sometimes grey or brown as well. And this salt is also used for cooking and industrial purposes, and mostly for de-icing. This rock salt, however, requires some purification to remove some non-salt materials. So the common salt or the table salt can be used as a raw material in order to make many other compounds. So common salt or table salt or sodium chloride is used as a raw material in some chemical reaction to produce a variety of compounds such as sodium hydroxide, baking soda, washing soda, and also bleaching powder. Let's look at the production of sodium hydroxide by using common salt. This process is called chloralkali process. It starts with a concentrated solution of NaCl in water, which is called brine. So in this process, an electrolysis setup is used. We have an anode and cathode, and we have a concentrated salt water or brine, and this brine is electrolyzed in an electrolytic cell, and at anode we see that chloride ions are oxidized to produce chlorine gas, and at cathode, negative electrode, water is reduced to produce hydrogen gas, and the product is sodium hydroxide. And the reaction is sodium chloride reacts with water to give sodium hydroxide and chlorine gas as well as hydrogen gas. Common salt can also be used to produce bleaching powder. Remember that the chlorine gas was produced in chloralkali process. So that chlorine gas is used to react with dry slaked lime or calcium hydroxide in order to produce bleaching powder. The process starts with dry slaked lime being spread out and chlorine gas being passed over it. Calcium hydroxide reacts with chlorine to form bleaching powder. Common uses of bleaching powder include whitening of clothes, water disinfection, paper pulping, as well as removal of weeds in gardening. Baking soda can also be produced from common salt, and this involves some raw materials other than salt, including ammonia, carbon dioxide, as well as water. So the process is that brine, that is concentrated NaCl solution, is saturated with ammonia. Then carbon dioxide is passed to this ammoniated brine, forming ammonium bicarbonate. This ammonium bicarbonate then reacts with NaCl to form bicarbonate or sodium bicarbonate or baking soda. The reaction can be written as ammonia plus carbon dioxide plus water plus NaCl gives sodium bicarbonate as well as ammonium chloride. The way we obtain sodium bicarbonate in this reaction is in the form of a precipitate and which is later filtered. Baking powder, a common leavening agent, is also prepared using NaCl or table salt as a raw material. Now, a leavening agent is nothing but a substance that produces gas in a batter or dough to create bubbles that help us make a product light or porous. You must have seen that sometimes baking dough is fluffy and porous. This is because of addition of this powder. Let's see how this reaction takes place. So, acid plus base releases gas, which is carbon dioxide. Here we are using baking soda as a base and tartaric acid to produce carbon dioxide gas and water and sodium hydrogen tartarate. Uses of this baking powder are not only in baking, but it can also be used as an antacid, fire extinguisher and an odor neutralizer. Let's see how production of washing soda takes place. A raw material used for producing washing soda is sodium bicarbonate. Now, sodium bicarbonate that is obtained from the previous process is heated and we form sodium carbonate. This sodium carbonate is dissolved in water and recrystallized to obtain washing soda. The chemical reactions include the first step, which is heating of sodium bicarbonate, which is the thermal decomposition, which gives us sodium carbonate, which is then reacted with water and recrystallization is done, with which we get washing soda, which is nothing but Na2CO3 10H2O, that is, it has 10 water molecules for each molecule of Na2CO3. Some uses of washing soda include laundry booster, soap manufacturing and also as a water softening agent. As we were discussing about washing soda, you must have noticed that I said each molecule of Na2CO3 has 10 water molecules. What does this mean? We can say that these salt crystals that we are forming are not really dry. A common example of this, the water in these salts is not in the liquid form, but these H2O molecules are chemically bonded to the crystal structure of the salts. A common example is copper sulfate, which exists as copper sulfate pentahydrate with 5 water molecules, but upon heating, we can see that a chemical reaction takes place where color changes and it becomes white and it becomes anhydrous copper sulfate, that is CuSO4 without any water molecules. So, we define this as water of crystallization, that is, in copper sulfate 5H2O is water of crystallization, which is water molecules that are part of its crystal structure. Another example is plaster of Paris or POP that we call in everyday life, which is called calcium sulfate hemihydrate. So, the formula of plaster of Paris is CaSO4 half H2O or hemihydrate. This means for every 2 molecules of calcium sulfate, there is 1 molecule of water or 1 water molecule for every 2 formula units. Plaster of Paris is obtained from heating gypsum. Gypsum is calcium sulfate 2H2O, which we heat at 100 to 150 degrees to form plaster of Paris, which is calcium sulfate hemihydrate. This plaster of Paris is mixed in water and it reacts to set into a hard solid, which is a much sought after property in order to create things like molds and casts or to fix fractured bones and also to create decorative wall art or in general some decorative art.